For the first derivative, when f prime of a equals 0, the point a f of a could be maximum point or minimum point or stationary inflection point. When f prime of x greater than 0 for all x in S, the function f of x is increasing in S. When f prime of x less than 0 for all x in S, the function f of x is decreasing in S. Here is the diagram about first derivative. When f prime of x less than 0, you see the graph, this two is decreasing. And for f prime of x greater than 0, this two is a increasing function. When f of x equal to 0, it could be maximum value or minimum value, or could be stationary inflection point. Now let's go to guided practice 2. Find the interval where the following functions are increasing or decreasing and classify all the stationary points. Stationary points means minimum, maximum, or stationary inflection. Increasing means we're looking for the interval where f prime of x greater than 0. Decreasing interval means f prime of x less than 0. So first step, you need to figure out the derivative. You will get negative 3x squared plus 12x. We need to factor this. You will get negative 3x and x minus 4. Then we draw sign diagram. First of all, you have to get the roots. x1 equals 0, x2 equals 4. So 0, here's 4. Choose any number you want. Basically, we choose 0, 1, 2, 3. Here's 0, so we cannot choose 0. I use 1. I plug 1 into this factor form function. When you plug in 1, negative 3 times 1 is negative. X minus 4, that's 1 minus 4 is negative. Negative times negative equals positive. So I will put this is a positive. Check this 0. Where you get this 0? You using this x. Single factor. That means all the power, you need to change the sign at this 0. For the 4, the factor is still single factor, so we change the sign. Therefore, you could say this is a decreasing, and here is a increasing, then decreasing. Therefore, for this 0 will be minimum. For this 4, it will be maximum point. So we write down increasing interval, that is from 0 to 4. For decreasing interval, you will get from negative infinity to 0 and from 4 to positive infinity. And a minimum point, that is at x equal to 0. And a maximum point, that is at x equals to 4. Now let's go to B. We still get the derivative of f of x. You will get this 12x to the third power minus 6x squared. Still factor 6x squared. We factor 2x minus 1. Then you will get the x1 equals 0 from this x squared. We set up this equal to 0, you will get the x equals 1 over 2. So we draw number line 0, 1 half. We will choose 1 here. Still plug into the factor formed function. We plug in 1, this will be positive. Plug in 1, positive. Positive multiplied by positive, still positive. Check 1 half as roots. Where you get that? The factor will be this. 2x minus 1. That's a single factor, so we change the sign. This is a negative. Then we go to this 0. Where you get this 0, you get from x squared. This is a even power, the sign stay. No sign change. Therefore, we can write down the increasing interval. That's over here. This is a decreasing. This is a decreasing. So for increasing interval, that will be 1 half to infinity. For decreasing interval, that is from negative infinity to 0. Then from 0 to 1 half. For this 0, it will be stationary inflection point. This 1 half, you could see going down then going up. Definitely that's a minimum point. Let's go to guided practice 3. Consider f of x equals this. Show that f prime of x equals this. And draw the sign diagram. So for f prime of x equals, make sure you have to do quotient rule. So we have x squared minus 3x minus 4 squared. We got to do 3x plus 4. We do derivative. Then times x squared minus 3x minus 4. Then here's minus 3x plus 4, you stay. Then you multiply by x squared minus 3x minus 4. We do derivative. Keep going. Denominator, I can factor x minus 4, x plus 1. So we get the x minus 4 squared, x plus 1 squared. Derivative for 3x plus 4, that will be 3. This one, you will get the x squared minus 3x minus 4. So we do distributive property for this. You will get the 3x squared minus 9x minus 12. The derivative for this, that is 2x minus 3. Then 3x plus 4. We do FOIL first. Then using this negative sign, do the distributive property. So we have 6x squared minus 9x plus 8x minus 12, which means 6x squared minus x minus 12. Don't forget I have negative sign here. So you get the negative 6x squared plus x plus 12. Then combine like terms. You will get negative 3x squared minus 8x. Then denominator will be x minus 4 squared, x plus 1 squared. That equals negative x, take out 3x plus 8 over x minus 4 squared, x plus 1 squared. Then draw the sign diagram. If you have a rational function, you will get the roots and also vertical asymptote line. You make a top equal to 0, you will get the x1 equal to 0, x2 equals to negative 8 over 3. Then you make a denominator equal 0, you will get the x3 equals 4, x4 equals negative 1. This is a vertical asymptote line. And we can draw sign diagram. You have 0, negative 8 over 3, negative 1, and here's 4. For negative 1, that's a vertical asymptote line. 4 is a vertical asymptote line. Choose a number plug in. Let me choose 1. I plug into this function for this 1. That's negative, positive. Denominator is a positive or positive because you square. Since I only have one negative, this will be negative. Then I check for this 4. Where you get this 4? From here. And this is a even power. 2 is even number, so you stay still negative. Then for this 0, single power, you change the sign, positive. Check negative 1, even power, so you stay. No sign change at negative 1. For negative 8 over 3, that's a single power, still change sign. Then you will see this is going down, going up, and going down. Then this one is going down. So you could say that the increasing interval will be from negative 8 over 3 to negative 1. Union set from negative 1 to 0. For decreasing intervals, it will be from negative infinity to negative 8 over 3. From 0 to 4. From 4 to infinity. For the stationary point, that means minimum, maximum, or stationary inflection. For vertical asymptote line, nothing to do with stationary points. So just check this. This will be minimum point. This 0 will be maximum point at x equal to 0. Now let's go to guided practice 4. Consider f of x equals this. We need to show that we're still using the quotient rule. So x squared plus 1 we square. And for x do the derivative, x squared plus 1. Then here's minus. Then you have 4x times x squared plus 1 do the derivative. You will get the denominator stay x squared plus 1 squared. 4x, that's 4 times x squared plus 1. Derivative for this is 2x, so minus 8x squared. Distributive property 4x squared plus 4. So you have negative 4x squared plus 4 over x squared plus 1 squared. So you get negative 4 take out x squared minus 1. X squared plus 1 squared. Then you need to factor the top. You get negative 4 x plus 1 x minus 1 over x squared plus 1 squared. Then we need to draw the sign diagram. Make a top equal 0. We got the x1 equals to negative 1, x2 equals 1. Denominator never be 0. So we just keep this. x1 equals negative 1, x2 equals 1. Then we choose 0, plug in. You will get, here's a negative, positive, negative. This is a positive. So you will get a positive. For 1 and a negative 1, both is a single factor, so change the sign like this. Therefore, increasing, that is from negative 1 to 1. For decreasing, that is from negative infinity to negative 1, and from 1 to positive infinity. So you could say this is going down, going up, then going down, which means negative 1, this point will be minimum point. This point will be maximum point.